This next example is another equation that is wrote in standard form where again we have x and y on the same side of the equation and then it equals some constant. And again, we're trying to get this so that it's in slope-intercept form. So we need to isolate y on one side of our equation. And again, this is basically we're solving for y as if we were, solving any other equation. We're using these inverse operations to help us accomplish that goal of getting y alone on one side of the equation. So to start this one off, we need to get rid of this x term. So again, we're trying to get the y term alone. And so to get rid of this 9x here, we're going to subtract 9x from both sides. So now we'll have 3y equals negative 9x plus 3. Then we have one more step to get y by itself, which is to undo this multiplication by 3. That means we need to divide by 3, and we're going to divide every single term in this equation by 3. So you have to make sure that you divide every single part of the equation by whatever it is that you're dividing by. In this case, we're dividing by 3. So 3 divided by 3 is going to make 1, which is perfect because now we have 1y or just y. Negative 9x divided by 3 would be negative 3x, and then 3 divided by 3 will be 1. So y equals negative 3x plus 1 is the slope-intercept form of this equation that we started with. So same equation, just wrote a little bit different. And again, the reason we do this is so that we can graph this. It's a lot easier to graph this than some of these equations that are in standard form. So again, slope-intercept form tells us two things, the slope and the y-intercept, and then we can use that to graph. Our next example kind of goes back to our first one that we did in a previous video where we have some parentheses going on. So before we can do anything, we need to get rid of those. So if you see parentheses involved in the problem, that means you need to use the distributive property. So that's what my first step's going to be, is I'm going to use the distributive property. And I end up with now 5x plus 5y equals 20 plus 3x. So again, you want to make sure that you're getting all the terms that can be combined together and again, working towards the goal of getting the y term alone. So in order to do that, I see that my next step is I need to get rid of this 5x here. So to get rid of this 5x term here, we're going to subtract it from both sides and it's going to be able to combine with this 3x over here. So I'm going to make sure I write it underneath that. So now I have 5y alone on the left-hand side of this equation. 20 still because that did not combine with anything. 3x minus 5x can be combined to get a negative 2x. Then we just have one more step to get y alone, which is to divide every single part of this equation by 5. So now I'm going to have y equals 20 divided by 5 is 4. And then we're just going to leave this as a fraction, so minus 2/5 x. Or again, so we write this so that it's more in the proper form of having the x term before the constant. This would be the same as y equals negative 2/5 x plus 4. So that would be the preferred way of writing it. Then our next example, again, we're trying to get this so that it says y equals. We're going to start off by just basically getting rid of this minus 21 by doing the inverse operation, which is to add. So we're going to add 21 to both sides. And then what's going to happen is that's going to cancel out on the left-hand side. We'll have 3y equals, we're going to have this as 12x plus 21 because, again, those are not like terms, so you cannot combine them. And then we have one more step, which is to divide every single part of this equation by 3. So now we're going to have y equals 12 divided by 3 would be 4. Don't forget the x next to it. And then 21 divided by 3 would be 7. So we're going to have plus 7 on the end. So that is the slope-intercept form of that equation.